Okay, I'm starting recording. So, we are interpreting quadratic graphs. So this is just kind of using, we're looking at quadratics, and now we're seeing how they're used kind of in real life a little bit. So it says NASA Nate launched a model rocket from the top of a building that is 80 feet tall. The rocket has an initial upward speed of 160 feet per second. The path of the rocket can be modeled by the equation h equals negative 16t squared plus 160t plus 80. So, if we're going to complete the table, what we need to do, let me edit this, is we're going to plug in what happens at each second. So after 1 second, our process would be h of 1 equals negative 16 times 1 squared plus 160 times 1 plus 80. All right, that's what we'd be that's how we would figure it out by hand. Now, if you have your calculator, that equals 224. If you have your calculator, you can just go to the graphing part of it and plug in negative 16 t squared plus 160t plus 80. Actually, I would do x. Just put negative 160 x squared plus 160 x plus 80 and graph it in your calculator. Okay? Graph it in your calculator. And then we're going to complete these for 2, 3, 4, 5 seconds, 6, 7, 8, 9, 10, 11, and 12 seconds. These things continue. So we'd have h of 2, h of 3. This is h of 4, and so on. Okay? So, what's the easiest way I could, rather than have to go through each one and plug in the number each time, what could I do? Put it in the calculator, graph it, and then once I graph it, what's the magic thing that can show me what the value is at each point? What are we completing right here? A what? A table?
Yes.
So that's what we want to do on the calculator. So in the graphing calculator, hit Control T. If you're at home using Desmos, you can use Desmos. Inside, if you hit the little the gear button, and then it'll pop up, you can see a little table. You click on the table, and you can always edit what the x value is in the table, and it'll pop up the correct y value. So if you hit Control T, what do you guys see then?
From the graph.
If you're in the graph, hit Control T. So graph it, and then hit Control T. Yeah, Control T for table. So you see a whole table, right?
Yeah.
Down the left-hand side, you should see the numbers 1, 2, 3, 4, 5, 6. What's right next to it? What's next to the 2, Ephraim?
Nothing. I don't know how to pull up anything.
Huh?
Where is this?
Did you plug it into your calculator?
For me, I'm not getting.
Did you graph it?
No.
You need to graph it first. So graph it first.
Just type in the whole equation.
Type in the whole equation. So you type in, instead of typing using t squared, type in negative 16x squared plus 160x plus 80. Because if you think about it over here, this is our x-axis and this is our y-axis. So in this case, that's h and that's t.
I got like 2 parallel lines.
How did you get 2 parallel lines? Did you put t squared?
If it's a straight line going up, is that correct?
Oh, you need to zoom out. Zoom out so you can see it better. Zoom out until it looks like a parabola. It should look like an upside down parabola. But you have to zoom out for a while. as you're doing that, I'm going to fill in what these should be. If we entered in h of 3, we entered in 3, h of 4, h of 5.
Mine's like super skinny.
It's going to be skinny, yeah.
Okay.
Did you zoom out?
That is quite the problem.
And then hit Control T for the table.
Oh wait,
Maddie, do you see it? What's yours look like? So type in the equation right there. Negative 16 times x squared.
oh it's 6. Oh it's 6. That's why I was so high.
So make sure you're plugging in the correct equation. And then when you do table, it should match up to what I've just written down. After 1 second, it's 224 feet. After 2 seconds, at 336 feet. After 3 seconds, you're at 416 feet, and so on.
It matches it.
It matches up. All right, now we want to graph the path of the rocket. So what I usually do is I set every fifth line is 100. So just label it. Okay, so we have 336 after 1, so, and then label the bottom. The bottom, the x-axis is your seconds. The y-axis is your feet. So it started at 80. It went up to 224, then to 336, then to 416, 464, 480, back to 464, back to 416, down again to 336, to 224, to 80, and then it goes off. So does it make sense, if it's a parabola, that it hits the same y values coming back down? So it's equidistant, because remember, we have an axis of symmetry. And so we can see we reach our maximum at 5. So here's our vertex, and that's our axis of symmetry at x equals 5. So if we look at this, what would be a reasonable domain for this graph? Where does it start at? What does time start at? 0. Approximately where does the graph go? Where does it hit? Where does the rocket hit the ground at? After how long? Okay. We could say 11, 10 and a half, whatever you want. What's a reasonable range? 0 to, what's the highest point? What's range? Ranges are, it's not time, but what? Height. How high did it go? Sadie, how high did this go? What was the highest point? 480, yeah. How high is the rocket after 3 seconds? Becca, how high is the rocket after 3 seconds? 416 feet, yeah. How long does it take the rocket to reach 336 feet in height? How long? Alex, how long does it take? How long does it take to get to 336 feet?
6, 8 seconds.
And what else? What's the first time it reaches 336?
2 seconds.
2 seconds.
8 seconds.
Yeah, we have 2 seconds and 8. How many seconds will it be 444 feet in height at least? Where does it reach at? It reaches at around 3.5. It stays up there until about 6.5. So we can say it will be about 3 seconds, right? It'll be 3 seconds in height for that long. Sean, how long does it take to reach the maximum height? How many seconds does it take to reach the maximum height? Sean, how long does it take to reach the maximum height? Huh? What do you guys think? 5 seconds, yeah. It takes 5 seconds to reach the maximum. And our maximum height would be that 480 feet. So if we asked, will the rocket go higher than 500 feet, what would we say?
No.
No. Okay, I'm going to flip it over. You guys will be able to finish this later if you need to. Let's go to the back side. It says, Luis kicks a soccer ball. The graph below shows the height of the ball over time. So what are some conclusions about the path of the ball you can draw from the graph? What are some things we could say? What are some things we can say just by looking at that graph? Okay, so the max height, let me use a different color. The max height is under 40. Okay, where does the ball start? Does it start up in the air? Or does it start somewhere else?
Starts on the ground.
Ball starts at ground level. What else can we notice? Ends on the ground. How long is it in the air? So it's in the air 3 seconds. Okay. So the x-axis represents the number of what that have passed since, should say, Luis kicked the ball.
Seconds.
Seconds, number of seconds. The y-axis represents the what of the ball?
Height.
The height. The starting height of the ball is 0 feet. So what approximately does the ball reach? What's the maximum height, you would say?
About 38 feet.
After how long?
After about 1.5 seconds.
After 1.5 seconds, yeah. And then the ball returns to the ground after 3 seconds. How long was the ball at least 20 feet off the ground?
About
Not 25 seconds. Where does it get to 20 feet first?
At
5 seconds. At 0.5, and it comes back below it at 2.5. So you would say it's at least 20 feet off the ground for 2 seconds. So what would we say would be a reasonable domain and range for this problem? What would be a reasonable domain?
0,
0 to 3, yeah. What about a reasonable range? To 38, yeah. From the ground to the maximum point. So you know how we have always said, oh, all these functions are always, the domain is always all reals, right?
Yeah.
How come it's not all reals now?
because it stops.
Yeah, because it stops. It starts and stops at specific points. The ball is not burying itself into the ground, and before we kicked it, the ball is not starting somewhere at negative infinity, then coming up and hitting our foot and then going up in the air. It's starting at 0. So that's why now when we have a word problem like this, we're going to have a domain and range that are set values. Okay. So that is all I have for that.